At the top of the show, we started loading the 3 first stage boosters. Next is the second stage. So let's check back in with Megan and Mick.
That's right, and in about 17 seconds, we expect SpaceX to begin loading RP-1 or rocket-grade kerosene into the rocket's second stage. And there you go. That's the call out there. So now we are loading both RP-1 and liquid oxygen into the Falcon Heavy rocket.
That is correct. We got RP-1 and liquid oxygen going into the first stage 3 boosters, and we just started RP-1 in the second stage. And we see RP-1's about 50% on the 3 boosters, and liquid oxygen is roughly about 30% on the first stage. So getting ready to start that. Next thing we'll do is liquid oxygen on the second stage. So things progressing well as we head towards a 526 liftoff.
And so to get RP-1 into the second stage, RP-1 has to first flow through the strong back, right? And that's that structure on the side of the rocket. Right now it's behind the rocket from this view that you're seeing, but this is the structure that provides propellants and electricity to the rocket until just before launch. And at T-minus 22 minutes, you're going to hear a call out to chill down that strong back, and that's to get it ready to load the really, really cold liquid oxygen into the second stage.
Yeah, that minus 341 densified LOX that we want to start flowing up through the what we call the TE when we transport and erect the vehicle, and then call it the strong back once we're on the vehicle. We want to get those lines chilled down so that we can get that LOX into the second stage. So that's a very important step to make sure that we don't break anything and keep going with loading today.
Yeah, because if you don't chill down the strong back in preparation, we could do thermal shock to the system, right?
That's correct. Yeah, we don't want to do that as we load these propellants. We want to keep moving, but things are looking good, and the team is proceeding forward.
All right. And so the GOES-U satellite is bound for geostationary orbit. NASA's Philip Hargrove has the complicated trajectory needed to get it there.
I'm joined by LSP flight design analyst Mark Hammett. Thanks for being here, Mark.
Thanks for having me.
Well, let's talk a bit about the GOES-U mission trajectory. So the G in GOES stands for geostationary. Can you explain what that means?
A geostationary orbit is a circular orbit around the equator about 22,000, just over 22,000 miles in altitude above the Earth. What's unique about that number is at that altitude, it takes 24 hours to complete one revolution around the Earth. What else happens 24 hours, one revolution? The Earth rotates on its axis in 24 hours, or one day. So if you pair those two up, put the satellite above a particular location over the Earth, as the Earth rotates one revolution per day, and the satellite moves at that same rate, the satellite will remain over that location over the Earth. Stationary, geostationary. In terms of what we're going to see on launch day, we don't have the performance to take it all the way to the mission orbit. Instead, we're going to go to what we call a geostationary transfer orbit, or GTO. And what that basically means is we're going to take it the majority of the way there, and what's most important for them is to have the sun in a particular location during that ascent sequence. So as they perform their design of how those all maneuvers would map out, they determined what the launch time would be to put the sun in the proper location for that ascent sequence.
So for this mission, we know that there's a long coast after the second burn of the upper stage. Can you explain why it's designed that way?
Sure. Right. This is a 3-burn mission. As you can see, the first 2 burns mapped out here. Those 2 burns occur in about 28 minutes. After that, then we do have this long coast period, as you mentioned. It's about a 4-hour coast until we get to the location of that 3rd burn. So we're going to get out here, we're going to do this burn, and we're going to raise that low side of the orbit from about 100 miles to about 10,000 miles in altitude. At the same time, you can see here the bend in the trajectory. We're also going to lower the inclination, or that angle with respect to the equator, from 27 degrees down to 4 degrees.
Thanks so much for explaining the trajectory to us. Great to have you here.
Thanks for having me.
Since 1975, GOES satellites have provided continuous imagery and data on atmospheric conditions and solar activity, resulting in more accurate and timely weather forecasts. Here's more about the legacy of NOAA's weather satellites.
It all began back in October 1975 with the launch of NOAA's GOES-1 satellite.
We've come a long way in weather forecasting since the early balloon launching days.
was launched, the GOES-R series. With this series came new advancements that included state-of-the-art instruments like the Geostationary Lightning Mapper and the Advanced Baseline Imager, or ABI. For nearly 50 years, the GOES satellites have provided a unique view of Earth. As the program advanced, so did the technology, allowing it to become the most sophisticated weather observing, environmental monitoring, and space weather monitoring satellite system that helps promote and protect the nation's security, environment, economy, and quality of life.
With the help of GOES data, NOAA weather forecasters predict above normal hurricane activity in the Atlantic Basin this year, with 17 to 25 total named storms, including 4 to 7 major hurricanes with winds of 111 miles per hour or higher. GOES satellites help predict the severity and the path of these devastating storms, and here's how.
So the polar orbiting satellites complement the geostationary. Since the geostationary, like 24,000 miles up, while they get great pictures, it's really hard to measure what is the state of the atmosphere from that distance. So the polar orbiting are basically flying a little over 500 miles up. And when you're at that altitude, you can sense what's in the atmosphere to a lot higher resolution.
Two things people always want to know about hurricanes are how strong is it and where's it going to hit. And microwave sounders can certainly help with both of those. The ability to see through clouds becomes really important. If you've ever seen a picture of a hurricane from space, mostly what you're seeing is clouds. And you can get a better weather forecast, a better prediction of how strong the hurricane is and where it's going to hit, which direction it's going to go, if you could see through those clouds and see the structure of the atmosphere, maybe even the ocean conditions underneath that. And so microwave sensors allow you to do that kind of thing.
You'd like that as precise as you can, so that only the people who are really going to be affected have to do something. The improved sensors that we've been flying allow a better understanding of the core of that hurricane and allow the forecasters to better predict precisely where that hurricane is going to hit. And when they do that, then you can narrow and shrink that cone of uncertainty and give a better prediction.
We hope to continue to improve the ability to do track forecasting. That's gotten so much better over the past couple of decades. Our 5-day forecast is about as accurate as our 2-day forecast was only about 20 years ago.
And increasingly, people are listening to the forecasts that they get from meteorologists. They have increased confidence. They see the improvement in forecasts as it relates to hurricanes over the last couple of decades. And when a hurricane watch or hurricane warning goes into effect, people take notice and they take action. And that's really encouraging to see.
Data from weather satellites is one way NOAA tracks severe weather, but as they have other tools, they use them. And it's not a tool, but he's our guest. That was kind of a weird read there. Joining us now is Nick Underwood. He is the agency's hurricane hunter. Not a tool, a hunter. Great to have you here. What is a hurricane hunter? I mean, it sounds pretty cool.
So hurricane hunters, we operate 3 of NOAA's aircraft, 2 WP-3D Orions and 1 Gulfstream 4. And we use these aircraft to fly into and around hurricanes to collect what we call in situ data. So actually sampling the atmosphere and the ocean in and around hurricanes so that the forecasters at the National Hurricane Center can have a clearer picture of how the storm is developing and how it's moving.
So what is inside a hurricane that we need to know that we can't get from other instruments?
It's that in situ data. It's the pressures, the temperatures, the humidities, the wind speed, the wind direction, the ocean sea surface temperature. All of this data we're able to collect with our aircraft as well as some of the instruments that we have on board. And all of that is vital for the forecasters.
All right. You've got some amazing video that you shared with us flying in a hurricane. We want to play that now. And you kind of talk to us about what it's like to fly inside a hurricane with 150 mile per hour winds.
So this video is from our WP-3D Orion. That's actually flying through Hurricane Florence in 2018. And on the P3, it's kind of like being on a wooden roller coaster that's inside of an automatic car wash. So a lot of vibration, a lot of getting bounced around, wind and rain slapping against the windows.
There you are.
It can certainly be a bumpy ride, yes. Our Gulfstream 4 flies up above, around, and in front of the storm to sample the high altitude atmosphere, usually at 45,000 feet. And all of this data feeds into those forecasts that you see on TV of the spaghetti plots of all the different ways a storm can go. And the better data we can collect up in the air, the more accurate those forecasts are going to be.
Right there, are you like catching some air right there? Looks like the bottom dropped out.
Yes, absolutely. You can get lightning a lot in these storms. You can certainly get some hefty bumps, a lot of turbulence, but it's exciting work and it's important work.
And we saw the G4 here today at the shuttle landing strip.
That's right. A lot of people got to check it out. You have one more tool that that you use, and that is a drone. I didn't even realize that we have a drone that's going to come flying in. Watch how this thing flies right into the set. See this? Thank you, John. Appreciate that.
There we go. Perfect.
In there. I didn't realize that you guys had tools like this. What do you do with this?
So this is newer technology. We've been launching these out of our P3 Orion the last couple of years, and so these are able to get down to altitudes that we can't safely get to in our aircraft. When we're flying through a hurricane, we won't fly below 5,000 feet, but these can get down to as low as 30 feet off of the ocean surface into what we call the boundary layer. That's where the ocean and the atmosphere are really interacting. That's where all of that energy is really flowing up into the storm. And so this can get us high resolution data at really low altitudes that we really can't get any other way.
How do they hold up? I mean, these are the most violent storms on Earth, and how does this guy do?
So typically these we'll drop these in the eye where it's calmer. They can work their way into the eye wall, and when they do that, they tend to just follow the wind. So they're not trying to fight against the storm, they're just going with it.
I was about to say, I mean, that's amazing that they can hang in there for that long to get back data. You're a former, well, you're still a meteorologist. Do you recall using data like this, and how would you work it into a forecast?
Oh, anytime there's a landfall hurricane coming towards the U.S., we have the hurricane hunters up 24/7. We're tracking every observation, every pass. They're seeing the real-time changes, right? There's no other way to get it.
Absolutely.
So what's the craziest hurricane hunting story you can tell us, Nick?
2 years ago, into Hurricane Ian, as it was working its way towards the coast of Florida.
Cat 5 at one point?
We were flying through at the point when it briefly intensified to Category 5. Wow. We were in the eye wall for what was 10 minutes, made it into the eye, were able to mark the center, launch a drone into the eye of the storm, work our way back out. That flight was the bumpiest I've been on in the 8 years that I've been doing this.
What about the lightning? Could you see it while you were in the eye wall?
Lots of lightning. I think there were over like 1,000 lightning strikes in the eye wall over the course of a couple of hours there. It was a night mission, so you could really see it flashing. It was very impressive.
Lightning flashing every second, being blown all around in a plane, and how did you feel?
It was certainly one of the more tense missions that we've been on, but all of our crews are highly trained. Everyone on that aircraft is focused on doing the mission, doing it well, making sure that we're gathering the data safely and that we're doing it effectively.
Nick Underwood, Hurricane Hunter with NOAA. It was great having you here. Thanks for sharing your stories. Not as cool as a bounty hunter, but Hurricane Hunter, I mean,
That's
what's
the
bigger
vibe.
than a hurricane, right? Yeah, that's great. Thank you very much, Nick.
Thank you.
Appreciate it. Well, back to talking weather satellites. GOES-U is the last of a generation that began with GOES-R. The next generation of NOAA's weather satellites will be GeoXO, or Geostationary Extended Observation. Here's more.
Like GOES-R, GeoXO will continue NOAA's 5 decades of critical Earth-observing data. However, GeoXO will have new technology on board. One of the new instruments will be an infrared sounder, which will allow weather forecasters to see the atmosphere in extremely fine detail.
It really looks at very fine slices of the atmosphere across a wide area so that it builds up sort of a 3D view of what the atmosphere looks like. And forecasters can use that information to be very precise about their forecasts, where a storm is going to be, how severe a storm is going to be. They can even do predictions of what the precipitation levels are going to be.
The sounder will also help detect quickly changing wind speeds and direction, which will assist in everything from hurricane prediction to aviation forecasts.
So a big part of the National Weather Service's mission is to forecast for aviation, for safety, and also looking at that fuel economy, looking at detecting the direction of the wind. So that capability is just going to be absolutely amazing for aviation and earlier detection and quicker detection of tropical systems when it comes to rapid intensification.
There will be 2 other new instruments on GeoXO as well. One will be an air quality instrument that will monitor and track harmful air pollutants, including wildfire smoke and volcanic gases, that will provide continuous observations and measurements of atmospheric composition, which will help improve air quality forecasts and alerts across the United States. Another instrument will measure ocean color, which helps detect and track threats to our lakes and ocean, such as harmful algal blooms and oil spills. Perhaps most critically, NOAA's GeoXO will also meet new needs for the data user community, including forecasters, researchers, and others who depend on receiving crucial environmental information across the Western Hemisphere.
These users are looking for advanced capabilities, and they've told us what they want to see in this next generation, which is going to start observing in the 2030s but continue into the 2050s. And with the changes on our planet and with the society's increased reliance on environmental information, it's really important to be able to serve this wider variety of needs.
GOES-U's 7 instruments will gather data that can help forecasters in many different ways. For more on that, let's go back now to NASA's Philip Hargrove.
Thank you, Daryl. I'm joined here by Irene Parker, the Deputy Associate Administrator for Systems for NOAA's Satellite and Information Service. Thank you for being here with us.
Thank you for having me, and thank you for saying all those words in a correct order and everything.
It's a lot of words. We'll get into it. So, yeah, you're a leader in NOAA. Can you tell us what it feels like to be this close to liftoff?
I'll be honest, it is extremely exciting. This is my second GOES launch, but my 3rd launch ever, and the excitement doesn't stop. I'm so looking forward to the Falcon Heavy and feeling the rumble. I'm just so looking forward to that.
Definitely a unique launch vehicle. And can you tell us what makes the GOES-U satellite unique relative to the other satellites in the GOES-R series?
Oh, definitely. So GOES-R series was mostly focused on weather and sun aspects, but this GOES-U has the compact coronagraph, which is an amazing instrument capability that was built by the Naval Research Lab. And what it basically does is it's going to look at the sun and it's going to be able to see a coronal mass injection. And a scientist basically explained to me what that was in like really simple terms. He's like, Irene, think of it as the sun burping up a whole lot of plasma, a lot of gas, and it's coming straight at you. And what this is going to do, this instrument, the C-Core, is it's going to basically be able to see that and detect that. And as it comes closer to the Earth, we'll be able to determine through the Space Weather Prediction Center at NOAA if there's going to be a geomagnetic storm. And if there's a geomagnetic storm, are we going to be able to make sure that our power grid is okay, our astronauts are okay, all those wonderful things. And this satellite is the first satellite in our GOES-R series, which happens to be the last one for the GOES-R series, to have this capability. And I'm like super excited about that. But what's amazing is this is just opening the door for us to do more extended observations in the future GEO series for GeoXO. And in that series, we're going to go and actually do things in atmospheric composition. We're going to do things in ocean color and really push the boundaries in environmental intelligence. So this is just the beginning with GOES-U that happens to have C-Core, but our next generation of GeoXO, it's going to have some amazing instruments in there. But the other thing I don't want to forget that GOES-U is still doing is for weather prediction, right? It is the bread and butter for hurricane forecasts, for lightning, for fire weather, all of those things this satellite is capable of doing. So it's just going to be amazing to see this 4th bird launch.
Thank you so much. Awesome stuff today and awesome stuff ahead. Thank you so much, Irene. Back to you, Daryl.
Thank you both very much. T-minus 15 minutes and counting. When you get your local weather forecast, chances are data from GOES satellites help create it. And no one knows that better than meteorologist Ginger Z.
Hi there, Ginger Z here at the Good Morning America studios in the Weather Center. We've got a whole team of meteorologists, and I know that atmospheric scientists all over the country and the world are excited for GOES-U. I know we are. Of course, that high-res everything. We're going to look at that lightning data. We're so excited for the aerosol information. It's just going to help forecast. And of course, we cover all of the biggest disasters, the wildfires, all the way to hurricanes. GOES-U is going to be wonderful. I've been talking to the space weather folks, and that coronagraph, ooh, having a dedicated peek at the sun every single day, GOES-U is going to be big. And we can't wait for this launch. So go NOAA, go NASA, and go GOES-U.
All right, whenever there's a big launch, we have thousands of people joining us. But real quick about the Ginger Z thing. I mean, she talked about aerosols. Aerosols are detected on GOES-U, but it's going to be really big in the next generation, right?
Oh, that's right. Atmospheric composition instrument on GeoXO. We'll be able to see it even better.
All right, looking forward to that. Whenever there's a big launch, we have thousands of people visiting the Space Coast to feel and see the rocket firsthand, including a very special group that we want to show you right now. A special group. There they are, about 80 middle school students. How are they doing? Giving us a big old wave there. They're here as part of the Students to Launch initiative, and they got a lot of energy. This is in partnership with NASA. These middle school students have traveled from all over the country to see today's launch, including as far north as New York and Maine, as far west as Nebraska and North Dakota, and south to Texas. Students to Launch educates and inspires students across the U.S. to understand the challenges and objectives of spaceflight missions, which can sometimes lead to careers in aerospace and astronautics. And that has to be one of the most enthusiastic groups I've ever seen at launch.
No, they were at my hotel this morning.
Oh, they were?
Very excited. Yeah, breakfast was a blast.
And so are you excited?
Oh, yeah, we're getting close. I can't believe it.
T-minus 13 minutes, just under 13 minutes and counting. There you see the rocket there. We've got a little bit of time to take a few more social questions. So let's pop one of those up now. You've been doing a great job, Alec, answering all of those. The question is, coming from Space Gal, why the U in the GOES-U name?
Oh, on the ground, the sequence that we name them is letters. So we've had the GOES-R series has had GOES-R, ST. Now we're at U. And so once it reaches geostationary orbit, it'll be renamed GOES-19.
It's just part of the nomenclature about how you name it on the ground and what happens to it when it goes into space.
Yeah.
And we have a few more questions to get answered here as we look and watch the Falcon Heavy on the pad there, getting ready to go from Launch Pad 39A.
It's cooking.
Yep. That's that LOX that's condensing the warm air in the atmosphere. All right, so we have Samuelo asks, how long will this spacecraft be in operation?
Okay, so the operational life is 10 years. We expect performance longer than that. It's planned for a period of on-orbit storage, and so we should have 15 years of use, but really we expect to be even a little bit longer than that as long as fuel usage goes okay.
It was fascinating. I heard in the press conference yesterday, they said that additional performance comes from the fact that that Falcon Heavy right there has a lot of performance in it for this satellite, so it could stretch it out another 5 years, as you mentioned.
That's 20. Right. It'll save us. It could save us a lot of life, and yeah, we will still have our GOES-R series satellites well into the 2030s.
All right, keep those questions coming. Use the hashtag AskNASA. We'll have time for one more question, if we can pop that up, as we count down T-minus 11 minutes and counting. Why Falcon Heavy and not Falcon 9?
Oh, man, this is a big satellite, and we're going to a big orbit to get up to geostationary 22,236 miles above the Earth. We need a big ride, and so what else than the Falcon Heavy?
Yeah, and I heard somebody from the Launch Services Program during yesterday's press conference say that Falcon 9 is right there at the limit of the weight of the GOES-U satellite, so that Falcon Heavy gives it the additional performance it needs to go up. And so with just a few more minutes left, your thoughts, Alec, as we get down, ready to count the final minutes before liftoff.
Oh, man, I'm bottled up. I can't wait to see it. It represents such a legacy for the program, and we're all excited to see this come together through the launch today.
All right, Alec and I are headed outside to watch the launch, and so we'll send it out to Megan and Mick for the remainder of the count and liftoff, and we'll see you again after the first burn of the second stage. Take it away.
Yeah, here we are at under 10 minutes from launch. Mick and I are going nowhere. We're staying inside here, inside the Mission Director Center, inside Hangar AE at nearby Cape Canaveral Space Force Station, because this is where we continue to monitor the launch team as we march towards that T0 of 5:26 p.m. Eastern Time here on the Florida Space Coast. So right now, Mick, the spacecraft team is beginning to transition the spacecraft to internal power. That's going to take a couple of minutes, right?
Yeah, spacecraft's working their procedures, verifying the health of the spacecraft, getting everything ready. They'll then transition around T-minus 6 minutes, 5 minutes. They'll transition to internal power, finish up that procedure, disconnecting from the ground power at the pad, and getting ready for launch today.
So the last time you guys were with us, the launch team has begun loading super cold liquid oxygen into the heavy second stage. That happened at T-minus 18 minutes. The next major fueling milestone that's expected at T-minus 7 minutes, and that's when SpaceX will chill down the Heavy's 27 engines on the boosters to get ready for engine startup.
Yeah, just like we talked about on the strong back, the team needs to chill down those engines so that we don't provide a thermal shock to all 27 engines. A lot of power there. We heard Daryl and Alec talking about that, getting GOES-U on its way. That's a very heavy satellite, so right on the cusp of a Falcon 9, but this Falcon Heavy is going to give a lot of performance today. And we're finishing up, Megan, as we're looking at the telemetry here. RP1 on the first stage is coming to fill levels, and LOX on the first stage is almost complete, and second stage LOX is about 50%. So we're proceeding very well with full fuel loading today, and things are going good.
That's awesome. And speaking of weather, we are launching a weather satellite, so we should talk about the launch weather. And we've been watching that in the hours leading up to our launch today. And right now we have great news to report. Launch weather is go for launch. We have found a hole within the some of the storms that are around our area. Launch Weather Officer Brian Cizik again confirming that we have found an opportunity to launch today at 5:26 p.m. Eastern Time.
Yeah, that team worked very quickly. Brian has definitely been very busy this afternoon, but working with Charlie Meyer, the SpaceX launch director, and Dr. Denton Gibson, the NASA launch manager, they moved our window 10 minutes, and they were able to find that sweet spot in the weather today to get things done. And we're hearing that RP1 loading is complete on one of the side boosters, and things are still progressing to completion of loading the Falcon Heavy.
In total, we are going to be loading 2.8 million pounds of propellant into the Falcon Heavy rocket that you see on Launch Pad 39A here at Kennedy Space Center. Again, so far we've heard call-outs that RP1 loading has been completed in the center booster as well as one of the side boosters. We expect to hear a call-out that the third and final booster will be completed for fueling of RP1.
Yep, the team's still progressing, looking at the telemetry on the launch vehicle. Things are progressing very well. The data
negative Y, fuel load complete.
And there we hear the negative Y, fuel load complete. So 2 side boosters and center core are complete with RP1, and they're finishing off liquid oxygen tanking into those 3 boosters. We should hear that here shortly, that LOX load will be complete as the spacecraft gets ready to go on internal power and continues processing their GOES-U satellite.
As with the spacecraft, we are also expecting the launch vehicle right now to be transitioning to internal power. Again, we are launching GOES-U today, the 4th and final weather satellite in the National Oceanic and Atmospheric Administration's GOES-R series of satellites. And once operational, GOES-U will become GOES-East and provide continuous imagery and atmospheric measurements of the Western Hemisphere. It will monitor weather and environmental conditions in near real time, which is really critical for weather forecasting and severe storm tracking. T-minus 5 minutes and 10 seconds to liftoff.
Falcon Heavy tanks are pressurizing for strong back retract.
There we hear the tanks being pressurized for retract, that strong back or transport erector as we use to transport out. The strong back will begin retracting here shortly, and what you will see at the top of the vehicle is those arms that are around the just below the payload fairing will open up, and once those open
Strong
up,
lower has started.
the strong back will then tip back slightly a few degrees, getting ready for launch this morning. And then as liftoff occurs, the strong back will fall back a little more to get out of the way as the Falcon Heavy leaves Launch Complex 39A.
Next up, NASA launch manager's go, no go poll, the final check to make sure the NASA team is ready for a launch that's expected in 5 seconds.
NLM, it's the LD on the NLM net with a final status check.
LD, everything's looking good on our end.
Copy that. Thank you.
Thumbs up from NASA, again, confirming that weather, right, was the big watch item, and that is not a constraint to launch right now.
Yep, the team has looked at all the data. Things continue to progress very well. Weather looks really good out there.
And countdown 1.
Dr. Gibson says things are good.
NASA is go for launch.
There we hear the final go for launch from Dr. Denton Gibson on the countdown net, and LOX load on one of the side boosters. There we hear the second call for LOX load complete on the 2 side boosters. LOX load is finishing up in the center core of the first stage booster, and then finishing up as we get down close to T0, the LOX load on second stage. So things progressing very well, Megan.
I do want to mention that Dr. Denton Gibson, this is his first launch as launch manager.
Yes, very happy to have him there. He has been doing very well as he stepped into the NLM position from his mission management position, and very happy to have him on console today as our launch manager for the GOES-U mission.
Stage 1, LOX load complete.
And there we hear the call out for stage 1. All 3 boosters now have RP1 and LOX on board, so we are just waiting for the remaining LOX to fill into the second stage LOX tank, and Falcon Heavy will be tanked and ready for launch.
And we expect them to finish fueling the second stage with liquid oxygen in about 20 seconds. With this
Stage
call out,
2, LOX load complete.
the Falcon Heavy rocket is completely filled with 2.8 million pounds of propellant.
Team has done very well to get to this point. We are so happy of everything's going, and as you can see on the screen right there, weather outside at Launch Complex 39 looks very good. We're about 1 minute and 50 seconds from launch, and the team's progressing down to get the flight computer ready to take over the launch vehicle. As you see there, Megan, the liquid oxygen being vented out, the plume from the humidity here in Florida. We get to see that. Looks like it breathes, and we just heard the call out for ground gas closeouts, which is finalizing and venting the ground lines that fill the pressure vessels in the Falcon Heavy, so that they're closing off all the ground connections, turning everything over to internal, getting the Falcon Heavy ready for liftoff.
And in a few seconds, we will arm the flight termination system, and Falcon will be in startup.
Falcon Heavy is in startup.
And that means the Falcon Heavy's flight computer is now in control and will guide the rocket through the last seconds before liftoff.
SpaceX launch director, go for launch.
All systems are go to send NOAA's GOES-U satellite into space to keep a watchful eye over the Western Hemisphere, helping scientists and meteorologists to issue timely warnings and forecasts.
T-minus 30 seconds.
This will be NASA's Launch Services Program's 16th mission for NOAA.
A great partnership over the years we've had. Looking forward to this launch.
15 seconds.
And here we go. 10.
T-minus 10.
9. 8. 7. 6. 5. 4. 3. 2. 1.
Go NASA and go you.
Liftoff of GOES-U, NOAA's newest
Vehicle
weather
is pitching
satellite to monitor the Earth and Sun in high definition.
Hear that all pressures on the engines look nominal. Things looking good as you see the Falcon Heavy soaring towards the heavens. All 27 engines powerfully lifting GOES-U on its trajectory and ascent into space.
A beautiful shot as we
Power and
track
telemetry nominal.
the rocket from the ground here. The rocket is now powering down for max Q. Max Q is the moment of maximum dynamic pressure on the rocket. Max Q expected at 1 minute 7 seconds. The vehicle is now supersonic,
Falcon Heavy is supersonic.
traveling faster than the speed of sound.
Max Q.
There we heard the call for max Q, maximum dynamic pressure on the Falcon Heavy. Vehicle still performs very well. All the data looks nominal.
A great shot from on board the rocket, looking down on the Earth that it is leaving. And all 27 Merlin engines providing 5.1 million pounds of thrust. Coming up at T plus 2 minutes and 28 seconds, the side boosters are going to shut off while the center core will continue on. Wow, what a shot there of, again, all 27 Merlin engines firing off 5.1 million pounds of thrust.
The side booster cutoff will be referred to as BECO. We'll hear that call out. And then when the center core shuts off later in flight, we'll hear that called as main engine cutoff, or MECO. Side boosters are all boosters are performing nominally. Everything's looking good with the 27 Merlin engines.
Side booster separation confirmed.
There we see BECO and side booster.
MVAC chill.
Side booster separation. The MVAC is being chilled down, getting ready for ignition once the center core.
NY boost back startup.
And there we heard the call out for boost back startup.
A lot of things happening here. So again, we have the 2 boosters that are going to be returning to the Cape here, landing at landing zones 1 and 2. These 2 boosters have 3 burns, so we're seeing a boost back burn
All
now.
vehicles are following nominal trajectories.
Essentially, these boosters have flipped back and are returning on a path to the Cape here. There will be 2 more burns, a re-entry burn and then a landing burn. And these are going to provide quite a show for folks that are here on the Space Coast, because you're going to hear those sonic booms, Mick.
Yeah, absolutely. We are looking forward to those sonic booms as the side boosters land at landing zone 1 and 2. We're about 26 seconds away from main engine cutoff and the center core separating. Once the center core separates, we will then have MVAC, which is the Merlin vacuum engine for space, start up and get ready for what we call SES-1. Number 1. Today we have 3 burns for this mission to get GOES-U on its way, and this will be the first of those 3 burns.
TY boost back shutdown.
There we hear the 2 side boosters have boost back shutdown.
And now we're going to watch live footage there. There you go, of MECO. Again, the core
and back ignition
booster separating from the second stage, and the MVAC engine on that second stage lighting up. You see that on the right side of your screen.
We're about 4 seconds from fairing deployment.
Fairing again is the two
All vehicles continue
halves.
to follow nominal trajectories.
Fairing separation confirmed.
And there we have confirmation the fairing has deployed. The fairings are brand new fairings for the GOES-U mission, and they will fall back to Earth and be recovered by the recovery ship Doug. But SpaceX will look to reuse those fairings on a future flight, along with the side boosters. As we see there, they're coming back to Earth to land on landing zone 1 and 2. So things are progressing very well here. We are about 1 minute and 23 seconds from what we call the entry burn, where the plus Y and NY side boosters will fire up their engines to start slowing down the vehicle as it gets ready for landing.
Yeah, a lot to watch. Again, the left side of your screen, we are tracking the boosters that are coming back to the Cape here. On the right side of your screen, that is the MVAC engine on the second stage that continues to burn as it makes its way into the correct orbit to drop off GOES-U later today.
Stage 1 FTS is saved.
There we hear the autonomous flight termination system was saved as it returns back to Earth, making sure the vehicle is in a proper configuration for landing.
The second stage is currently taking GOES-U across the Atlantic towards southern Africa. And this is the first time, actually, a GOES satellite is launching on a Falcon Heavy. Only the second time NASA's Launch Services Program is using a Falcon Heavy.
Yeah, we launched our first Falcon Heavy with SpaceX back in October of 23 with the Psyche mission. And the side boosters actually that we used on the Psyche mission will be used for our future mission, Europa Clipper, this October. So brand new hardware today for GOES-U, and everything looks like it's performing very well. All the telemetry, everything looks nominal for the flight so far today.
Yeah, those who typically watch our launch broadcasts.
Entry burn startup.
There we heard the call out for entry burn startup. The vehicles are slowing. You can imagine this as a brake on your car where it starts slowing the boosters back down very quickly as they
entry burn shut down.
And there we hear the shutdown as the boosters have slowed down. Next thing we will see is the landing burn.
NY FTS is saved.
At landing zone 1 and 2.
Beautiful
All
imagery
vehicles
again.
continue to follow nominal trajectories.
From the ground as we track those boosters make their way back to the Cape. We saw some birds fly into the camera's view as well.
Everybody wants to see the landing of the side boosters. As we said earlier, Megan, the landing will be exciting for a lot of people to see. Getting 2 side boosters coming back to landing zone 1 and 2, we will get those sonic booms. I know that you here in the MDC, we will get some...
NY transonic.
We will
Stage 2 FTS is saved.
We will get some loud shaking right here in the Mission Director Center. I know a lot of people right here in Brevard will be excited when they hear the sonic booms.
NY landing burn.
Landing burns has started up.
Terminal guidance.
Wow, look at that. As it guides its way back down. Woo! Just heard the 2 sonic booms here in the room.
NY landing light deploy.
Our monitors shaking as we watch
amazing.
These 2
that
boosters
is just
land.
Awesome to see the 2 side boosters choreograph their way down to landing zone 1 and 2.
NY landing confirmed.
We have successful landing of the 2 side boosters. Everybody looks great on the landing zone 1 and 2 as MVAC continues its mission with this first burn. And there we heard the call out for SECO, which is SECO 1, second stage engine cutoff for this first burn. And things look very good. The trajectory looks, we hear the call out there that nominal orbit insertion, everything looks great on the second stage performance for this first burn.